Hello everyone, we are Team 14 and the 452 interim presentation where we will be analyzing and redesigning a handheld tape dispenser. So the product we'll look at is a handheld tape dispenser that's used to dispense various types of tapes at different lengths. It's composed of a replaceable blade, a roller, and a plastic handle along with other components that we'll talk about later. The components are fixed together to create a device that can allow a worker to adhere the tape to a surface, such as sealing up a box. Once the tape is at the desired length, the user can apply tension and push down on the tape with the blade to cut the tape. The target customers are mainly industrial warehouses where the employees would be working in a packaging environment, and the production volume is likely in the order of 100,000 units. So here's an exploded view of our product with all its various components labeled and numbered. The main components would include the tape holder along with the tensioning system, the roller, handle, and the replaceable blade, as well as the tape wipe down blade. Taking a look at who would use this product, we've identified the primary customer as logistics warehouse administrators, where the workers within those warehouses would be using the tape to form and close boxes, as well as applying labels to the tops of those boxes. And then our second customer was identified as family or personal use for item repair or packaging, such as when a family moves.
This slide shows the assembly sequence analysis. From the explore view of the tap dispenser, we can see the tap dispenser separated to two functional parts. Which one is a blade part and another one is a tape holder part, and also the two base parts, the base plate and the handle. There are two sequences of the assembly sequence. The first one is left to right. It means we will start assembly from the base plate, and the second one is bottom up, which means we will start from the handle to assembly. There is a table to show the difference between the sequence 1 and the sequence 2. From the table, we can see the sequence 2 is better to transferring and handling, and better to do the fastening and the joining, and also better to do the assembling in parallel. The only thing the sequence 1 better than sequence 2 is a test sub-assembly. As a result, the sequence 1 got 9 points and sequence 2 got 12 points. So we will choose the bottom-up sequence to do the assembly.
For our fast diagram, we decided the primary task function would be dispensing tape. The secondary tasks which allow you to achieve the primary task are cutting tape and rotating tape. The subfunctions for rotating tape would be holding tape. The subfunctions for the supporting functions would be preventing user injury from cuts, reducing jamming of tape, and add comfort. For our function component mapping matrix, we found that the components critical for the function of the tape dispenser are the handle, base plate, tape guide, roller, tensioner, tape cutting blade, and the tape blade holder. The other components aid the supporting functions, but are not necessary to the function of the tape dispenser, so they can be theoretically removed. For our BOM, we used a production volume of 100,000 units. The assumptions we made in our calculations were that all plastic components were made of ABS and that all steel parts were bought in bulk. We used the Made of McMaster to help us in determining some of the material costs. From our BOM, we can see that the most expensive component to produce is the base plate. For our secondary customers, we wanted to bring the cost down since they would benefit from a cheaper product. So we redesigned the base plate to be made of plastic, which brought the cost significantly lower. For the functional differentiation table, both customers will get a product that cuts tape, rotates tape, holds tape, prevents user injury, reduces jamming, and adds comfort. The main difference for the secondary group is a much lighter product. This is because the secondary group requires a product that's easier to carry around and manipulate.
Here, as you can see from the table, the only part that will differ from the other variants would be the base plate, and all of the rest of the components will remain the same. In terms of the assemble sequence, the standard sequence is generated from the fishbone diagram, which starts from base plate, and it has two variations defined at the base plate. For our delay differentiation assemble sequence, the base plate assembly is moved between the handle and tape holder ring. In this way, we have only one variation at the beginning.
In terms of product differentiation, on the left, you can see the original base plate with the 5 holes for the original fasteners that protrude from the back of the base plate into the inner mechanism of the tape dispenser. And then on the right, you can see the new version of the base plate with 5 protrusions instead of fasteners, hopefully lowering that assembly and manufacturing time, as well as replacing the base plate spring and the tensioner axle with one large post. For common interfaces, this is the model of the original tape dispenser and base plate. The common interfaces are shown in yellow. They are the cylindrical rods, formerly fasteners, that will be used between the two products for that product differentiation. There's also a caveat with that upper right fastener or rod. In the rod design, it has a flared base, as well as includes the axle. So that's a couple more components lessened in this product family differentiation.